Hey, would you like a sneak peek into the future of wellness? We talk about longevity and anti-aging quite a bit on this show. And on this episode, I bring on two experts, super smart experts, who share their ideas about the future of medicine and how it's going to be personalized, how it's going to be predictive and rich from your own data, be that your hormones, your blood tests, your microbiome, your proteins, and other data from your own body. Plus, we also discuss how the complete information on your health is going to be available in the palm of your hands. Stay tuned for a really exciting episode. Are you looking to get thicker, fuller, and stronger hair? Then make sure to check out fullyvital.com. The team has come up with 4 unique products that stimulate hair follicles in different ways to wake up tired hair follicles and get them growing again. So to get thicker, fuller, and stronger hair, make sure to check out fullyvital.com and use the code anti-aging-hacks for 15% off your order. Are you enjoying the episodes on this channel? Then please make sure to hit the subscribe button down below so you can get notified when we release new episodes. Our goal with this show is to help you slow down your aging and look and feel younger and sexier so you can live your best life. So once again, click on the link below to subscribe so you can get notified when we release new episodes. Now, let's get on with the show. Hello, my friend, and welcome back to the Anti-Aging Hacks podcast. Today, I have not one, but 2 very credentialed guests. The first one is Dr. Leroy Hood, who's developed the DNA sequencing technology that made possible the Human Genome Project and is the co-founder of the Institute for Systems Biology. He's a pioneer in the fields of systems biology, proteomics, and P4 medicine. He has won the Kyoto Prize, the Lasker Award, the Heinz Award, and the National Medal of Science. Dr. Leroy Hood co-founded the Institute for Systems Biology in 2000, served as its president from 2000 to 2017, and now serves as Emeritus Science Advisor. Nathan Price, who's the second guest, is the Chief Science Officer of Thorne Health Tech and professor at the Institute of Systems Biology. In 2019, he was selected by the National Academy of Medicine as one of the 10 emerging leaders in health and medicine. He received the Grace A. Goldsmith Award for his work on scientific wellness and has co-authored over 200 peer-reviewed scientific publications. With that said, Lee and Nathan, welcome to the Anti-Aging Hacks podcast.
Great. Thanks, Faraz. Great to be here.
Like I was saying earlier, I think you two might be the most credentialed guests I've had on the podcast, so I'm super honored to be asking you a lot of questions. But so in that sense, please go back and tell us how you got into health and wellness and what do you do? What do you do now?
So I'll start. I probably got into health and wellness when I was 6 years old and my youngest brother was born with Down syndrome, which no one had any idea as to the cause at that time. And I was intrigued by, the complexity of this whole process, apparently, and where we needed to go next. And that led to a career as an undergraduate at Caltech, an MD at Johns Hopkins. And then later, I went back and got a PhD at Caltech and went on and was a faculty member there for 22 years. And I think remember very clearly when I started at Caltech in 1970, the whole question of the complexity of human beings and how we deal with it. So 1 was a question of how do we measure this complexity? And 2 was a question of how we interpret the complexity. And 3 was a question of how we could convert that insight into better health for human beings. And that really is the trajectory that I followed. From Caltech, I went to the University of Washington and started the first cross-disciplinary department, molecular biotechnology, that really pioneered many of the genomic and proteomic and phenomic kinds of techniques that we're now employing. And then in 2000, started the Institute for Systems Biology, where we began that translation of coming to understand how this complexity operated and thinking in terms of populations, but populations at the individual level of how we actually optimize wellness. And most recently, I started a nonprofit called Phenome Health, and this is dedicated toward creating in a sense, a second genome project, looking at 1 million people over a 10-year period with genome phenome analyses to understand their complexity and translate it for each of them into how to improve their health.
Beautiful. Nathan, you want to go next?
Sure. So I'll start. I first did a PhD in bioengineering at the University of California, San Diego. This was looking at building computer models of cells and also the human body. Basically, how do you take all the food that you import into yourself, go through thousands and thousands of different reactions and make your body? And how does that happen? And how do you simulate that? So I come in really from kind of the computer science, now AI kind of analysis point of view into how do we understand health data in a deep way. Out of my PhD, I had done well there, so I got a faculty job straight out of grad school, which is pretty unusual, at the University of Illinois in Urbana-Champaign. I deferred it for 2 years because Lee was a huge hero of mine in science, and I wanted to go work with him and learn about systems medicine. So I joined up with him at the Institute for Systems Biology for my postdoctoral studies on leave from the University of Illinois. I then went back to the university, was there for 4 years, and Lee and I had stayed close contact during that period. He had just gotten this $100 million grant from the government of Luxembourg, which is quite a story, which we could get into. And that was enabling for me to move back to ISB. And so from there, I really became very interested. I built lots of models of disease and had studied, a wide gambit of these things, but became really convinced that we were aiming at disease much too late and needed to be earlier. And I'm sure we're going to get into all that. That led to then a partnership with Lee on that front, the Pioneer 100 and other things that we'll get into later. And I became really enamored by that. And we spent about 10 years building that out, starting a company, which we'll talk about, and a whole bunch of different things of that nature. About 2 years ago, I became interested in trying to translate a lot of this out to society more directly. So I got an offer sort of out of the blue that from Paul Jacobson, who recruited me at that time to become CEO of a company called Longevity, which was a health AI company. We then merged that company with Thorne to form something that we called Thorne Health Tech, and then we IPO'd that on the NASDAQ in 2021. And I became chief science officer for that company, which I am now. And what that's really about is trying to take this vision for scientific wellness that Lee and I are talking about, and that's the focus of the book, and get that out to people. So Thorne currently has about 5 million customers, 46,000 physicians and healthcare professionals that we work with. And so basically what this is trying to take a lot of what we'll talk about in the science in the book and make it easily and vastly accessible to people on a daily basis.
Mm-hmm. Wow. Yeah, there's a lot we can get into there, and we will quite a few of these things. But first, I want to start off with something that you describe in the book many, many times, which is the systems approach to health and wellness and longevity. So why are you two such a fan of it, and how did it come about?
So I started thinking about systems approaches to biology in the late 80s and actually put a few grants into NSF and never ever got any of them funded. And in fact, when we started the Institute in 2000, I remember a good friend of mine at MIT saying this systems biology is all hype. And of course, it's turned out to be anything but. But this systems approach really is about how do we deal with this complexity? And at its heart, the answer is we deal with it by generating an enormous amount of data on individuals. And we generate data that deals with the brain in itself, with the body in itself, with the gut in itself. And we come to understand that health in the context of how can we optimize the wellness of individuals and so forth. We convert the enormous amount of data that we can generate with DNA sequencing and protein quantification and metabolite quantification, and now digital health and the gut microbiome. all of that gets converted into biological networks that operate relevant physiologies for human health. And we can readily see if they have deficiencies and how they might be corrected and so forth. But ultimately, what we'd like to be able to do is to take this enormous complexity and to be able to use the modern techniques of AI to be able to understand, as we put the enormous amount of data from an individual into this context, what the gaps and deficiencies and options are for each individual, and to be able to deliver that with AI in a way that physicians can readily, A, understand what to do, and B, understand the logic of what follows it. And of course, this is something that both Nathan and I have been very interested in. So the systems biology is global and holistic. It's data-driven, and it's model-driven through biological network, and it gives us deep insights into the complexity of individual systems and the interaction of the systems one with another. Did you want to add anything to that, Nathan?
Well, only just to say, I think you covered systems biology well, just at the level that as an individual thinks about optimizing their health, right, extending their health span, there's all kinds of practical things that people can do that are basic table stakes that have existed for a long time. But if you want to get really precise about it, or you start thinking about ways that you might be able to intervene or push off disease into the future and so forth, there's enormous complexity into what's happening in the body. And the really cool thing now is because of new technologies, the AIs, all that system, you can wrap up a lot of that complexity to give people really actionable items that you can make a difference. And I'll just give one example. So one that was quite interesting when we were looking at a vast amount of data from people was whether or not by taking lifestyle interventions, you would see a change in, for example, LDL cholesterol or something like this. And what it turned out was that you could identify who was able to lower LDL cholesterol or not, and it was totally predictable by genetics. And so as you just start putting some of this information together, you can start to give people a view of what are the kind of things in your body that are easy to change because your genetics will work with you rather than against you. And you can start to have kind of an ROI on your health effort of the areas that will be most interesting to you. And so I think that really comes from this network or systems point of view of trying to understand how all these pieces fit together.
Yeah, that's really interesting. I read that anecdote or the story in your book about the LDL cholesterol. And presumably, if a doctor that's even an expert in heart health would not be able to have connected those dots outside of having the genomic information, correct?
That's absolutely true. And in fact, the doctors will basically never do it until you turn it into a product or a test that goes into their office that makes it simple, actionable, easily identifiable, clear to the patient what's going on. All those kind of things are really essential to make that, get into people's lives and get the benefit from it.
Yeah. This is, again, as Lee said, this is incredibly, or at least seems incredibly complex from the outset because there's so many things you got to account for. There is genetic data. That's a lot of that. There's metabolomics, there's biomarkers, there's the proteins that are being created or formed in the body. And then you have to basically get a lot of individuals together, and they're different in a lot of ways. So it's really cool that AI can actually bring that data together. And I'm really interested in some of the insights. But before we go there, you've included a diagram in your book that talks about the periods of wellness that people have, and then there's a transition period, then we go into disease states, and then death. But now there's a new model of what you envision the future to be, which is wellness and transition, back to wellness, transition. So please talk about what you mean by that model and how that would manifest itself in somebody's life.
Well, I can start again. The idea is, what do you mean by health? And we would argue health is really three different things. You start life usually well, so that means one dimension of health is wellness. But all of us reach a point where we transition from wellness to disease. And what is exciting by data-driven health is we can actually measure these transitions often years before the clinical disease comes up. And then, of course, the third thing is disease that progresses to a course of action, either reversing itself and taking you back to wellness, most commonly, or occasionally, obviously, leading to death. But the really important point is wellness is really a continuum. And we would argue that the average person probably has 20%, 30% of their wellness potential, and we can expand that far beyond what it is now with actionable possibilities that come from this data-driven approach. So one of the critical questions is, how much energy do you want to put into being healthy? And where this really counts is what happens at the end of your life, because the healthier you are as you go along, the better off you're going to be as you move into your 90s and hundreds if you're fortunate. The second thing is, because we can look at most chronic diseases and see the transition early, we then have the option of reversing those diseases at that early stage before it ever gets clinically manifest. And the early stage is simpler. So the therapies we'll use will be orders of magnitude simpler than what we have to use for frank cancer or frank heart failure or those kinds of things. And of course, the third thing is, with the data-driven approach, we can deal with disease, and it's called precision population disease, more effectively. But our enormous preference is to think in terms largely of wellness and prevention. And in the future, we'll be increasingly avoiding chronic diseases. So, Nathan, did you want to throw a few more comments into that?
Sure. So it is a very different model, and it requires a pretty big upheaval of the way we think about medicine and even the way that we think about medical science. So because we intervene typically late stage, and you remember we get into this notion of, typically a single drug given for a condition after there's serious symptoms that you have to stay on for a long period of time. And the truth is that approach has not worked terribly well for chronic disease. And as Lee mentioned, as you get further and further along in chronic disease, it's more and more complicated and it's harder and harder to reverse. So what you actually want is to dive into that very earliest stage and do reversal. Some of these things are very familiar to people. If you think about diabetes, right? Late stage interventions for diabetes are grotesque. You lose the, pain. Foot amputations are up something like 30% in the United States over the last few years. Like, it's terrible. Mm-hmm. Early stage interventions for diabetes are eat less sugar, eat more fiber in your diet, simple kinds of things. And you can get very precise on some of those edges as well. And so one of the things that is really important here then is, even from the very earliest research stage, if you're thinking about all the studies, and there's billions and billions of dollars spent on late stage case control studies, if you go in there with these big omics data types or all this modern technology, you see hundreds, thousands, tens of thousands of differences or things that you're having to suss through that include the cause of the disease, downstream consequences, and responses, proper responses of the body trying to recover from those issues. And they're all mixed together. If you look early, and we've done this with genetics, if you look at people that have high to low risk for example, coronary artery disease, of all the proteins we looked at, there was only one that was correlated with that genetic risk. And it's PCSK9, which of course turned into the biggest blockbuster drug of the last 10 years on that topic. And there's many of these cases. So by focusing early, you get these much simpler, much more likely to be causal signals, and you can reorient the interventions to be much safer, much smaller, to deal with those things before you have this whole cascade of problems that it's almost impossible to reverse. So that it's really a big issue.
Yeah, I love that. And another statistic that I learned from your book, which shocked me basically to my core, was um, how or lack of effectiveness of a lot of pharmaceuticals in treating some of these late stage diseases. And the numbers that were in the book were one in four, or these drugs might work in one in four people, or 1 in 24, which is about 4%. That seems crazy because the FDA has they do two things, right? They make sure it's safe and they make sure it's efficacious. So are they missing the second pillar of this? Or like, how are these drugs not working in so many people?
You want to take that one first,
Sure,
Nathan?
I'll take that one first. So it's a really important point. And so if you sum that all together, the top 10 selling drugs in the United States work for about 10% of people. And that comes out of a Nature paper, an analysis that Nick Shork at UCSD did a few years ago. And so what people miss, or what's in there, is it's not that the FDA didn't do their job. Like, the FDA did their job and there's efficacy. But just imagine for the moment, you have a drug that is 50% better than standard of care, right? Let's say it's 50% better. But what that might mean is that of 1,000 people, usually you get you have 3 incidents that are bad, and now you have 2. So the numbers are a little bit, so you have to get your mind wrapped around that. So it says it's 50% better. You went from, instead of 2, instead of 3, you had 2. So, it's much improved. But in absolute terms, most of the people on that drug didn't actually experience a benefit. This is known as number needed to treat in medicine. Mm-hmm. And, we don't want to just, throw shade at that or anything. It's a very hard problem. But the issue with precision, and this is what precision medicine is about. And when we talk about scientific wellness, that's in essence similar to those concepts of precision medicine, but much earlier, like looking at precision health or scientific wellness. And so basically the idea here is, how do we get the drugs to the people who actually need them? And if you intervene earlier, the other thing is you can use much safer interventions than a lot of drugs are. And you can think more about combinatorics and ways to personalize to try to get efficacy to be a lot higher. So those are a bunch of the issues that arise in terms of just dealing with that issue of that we really live now in the time of imprecision medicine, where you're hopeful that something will work, but you don't really know it in advance.
Mm-hmm. Okay.
And the other thing I think we can say that's clear is that with this data-driven approach to analyzing blood analytes every 6 months or so, we probably in the first 10,000 patients we study will come up with markers that will let us to distinguish those that will respond to a given drug from those that won't respond. So in the future, you have the possibility of being able to reduce 90% wastage in drug and focus on the 10% that actually can respond. And of course, people and systems, health systems will love this. Pharma is going to be less enthusiastic about it for obvious reasons.
Mm-hmm. Okay, I want to get into this program that you guys had launched, both of you had launched, called the Pioneer 100 Wellness Program, which I think was friends and family at that point. But then that spun off into a whole startup of its own, and you had thousands of patients. So tell us about why you started the Pioneer 100 Wellness Program and how that formed a company at the end.
You want to start? You want me to start, Nathan?
Why don't you start that one, Lee?
Okay. Well, Nathan and I, in probably 2013, started thinking for the first time. And these were after some very classic studies had been done by Mike Snyder and Larry Smarr and Eric Alm on themselves or on individuals about making detailed measurements of their blood proteins and metabolites and things like that. We started thinking about, well, let's put together a population. And what we initially concluded is that we would ask 100 or so of our friends to do this. And an interesting story is I remember in early 2014 going to NIH and talking with one of the leaders there at NIH about this wellness program, and just asked him whether we could hope to get funding from NIH. And he said quite strongly, no, NIH is interested only in disease. We don't deal with wellness. You'll never get this funded here, which was true. And we went out and raised philanthropy and things like that to do the 100 Pioneer. But the whole idea was to take a data-rich approach to analyze proteins and clinical chemistries and metabolites in the blood, to do the microbiome, gut microbiome, which assesses the diversity of microorganisms in the gut, and they're an absolutely critical part of health. And then we use the Fitbit as a digital device to measure activity and sleep and a few other things like this. And the results from that 100-person project were absolutely startling. We demonstrated that being able to quantify wellness in this way led to a whole series of interesting, actionable possibilities that were specific for each individual, uniquely allowed the individual to improve their wellness and or avoid their disease. And it was the beginning, really, of true personalized population health. There were beautiful hints of we'd be able to measure your biological age, because we had a broad range in there, and that later turned out to be true when we looked at the larger population from a company we started that was aimed at bringing scientific wellness to the consumer population. But the whole vision emerged from this, and it was clear this was a transformational event. And I would say if you look at the history of health for the last 3,000 years, what is really remarkable is the Greeks had it right back in 2500 when they said, look, there are three things that determine your health. One is fates, the second is your behavior, and the third is your environment. And if you change fates to your genome, that's exactly what the data-driven system looks like today. And in fact, the phenome are those three things: your genome, your behavior, and your environment, and how we measure those kinds of things through the analyses that we've talked about. But what the 100-person project then did is persuade us to recruit a terrific team that started the company called Airvale, that eventually ended up recruiting over a 4-year period 5,000 individuals, and for each we had data clouds of varying length of time. And I'll just make the point that in the subsequent years after Airvale ended, and it ended for interesting reasons we can talk about, we've probably published of the order of 30 papers from that data set, and they've laid out all of the dictums that drive our whole vision of data-driven health and precision population health and things like that today. So Nathan, do you want to add a dimension or two more?
Yeah, I'll add on to this in the sense that, the project was really transformative, as Lee was alluding to, because at the beginning we got tons of pushback. Like, people were really upset about this project, which was kind of funny. And we got a lot of pushback that studying people who, without having a particular disease lens on it was a waste of time. And so we actually did an analysis later on from our lab. Lee and I had a joint lab for many years. And when we did that, we looked at the total, like our funding input, and scientific wellness was 4% of our funding. and it was 55% of our citations in terms of the papers that resulted. In other words, it was all the best science that was coming out was coming from this.
Mm-hmm.
And so what was really startling, I think to a lot of people, was as you start to take all this dense layers of data together, it turns out that studying wellness is incredibly informative. And we can get into a number of those things in specific here in a moment. But it was incredibly illuminating. I was on a panel a little bit before the pandemic, before we all got pushed back into our homes for a while, with the chairman emeritus of Harvard Medical School. And he made it, the way he put this, and I really like it, is that healthcare is the only industry that does not study its own gold standard, which is wellness. And so this was really the beginning of studying wellness in a deep way, the same way we'd study disease. And it turns out that you learn so much about how the genome predicts your response to lifestyle intervention. Turns out there's a huge genetic component to that. You find out how the microbiome, its state and its health can actually be predicted from metabolites in the blood because these systems are all interconnected. We learned how the microbiome changes as a function of age, and that if you age healthily, your microbiome becomes more and more unique and specific to you. It looks less and less like anyone else's microbiome in the world if you stay healthy. If you get on a bunch of drugs or you get put in hospitals, or that goes away. But if you stay healthy, you're on this like co-journey. And we can go into a million other things on and on and on, but you start to see an eye-opening of all the different things that you can learn by putting these pieces together. And it's why, both Lee and I are on such a mission to try to amplify that information and then get it in formats where people can take advantage of this, and it makes a difference in their lives and their health and how long they stay healthy and vibrant.
Yeah, I love this. And one of the things I see, especially being in the health and wellness world, is that a lot of people are frustrated basically by the modern medical system and how you get a single molecule or even a cocktail of drugs in your 40s, 50s, 60s to manage a host of symptoms without any due care for what's actually causing those symptoms. And that's why at least the people that I talk to are more interested in, Chinese traditional medicine or even Ayurvedic medicine, which it seems antiquated, but at least it's addressing the entire system, which what you guys are going after. But now you've got the advantage of having science and metabolites and measuring things that we could have never dreamed to measure like 3,000 years ago, right? We didn't, they probably knew about the gut microbiome, but there was no test to see how you're doing. And so science has come a long way, and I'm super excited. You touched on something, Nathan, which is the genome. And Lee had a part in the human genome or decoding of it in 2003. But the full genome sequencing has just become available recently, and the prices have gone down. So you're saying the postulation that you guys have is that the genome is incredibly important when it comes to health, and the sooner you can get it fully sequenced, the better off you are. How would people go about getting this genome sequence, and what can they make of that data? Is it actionable?
Yeah, it's definitely actionable. So actually, if I could, I want to make one quick point, and then I'll dive into genetics,
Sure.
Which is, I just want to come back to what you said on traditional Chinese medicine and Ayurvedic medicine and all that, because it's partly, this term of scientific wellness sits at that heart of this interface between the East and West in a sense, because it really is about that, pulling from traditions or things that we think about in wellness and making that, deeper, richer, and pulling together like the tools of science that we have, that have been developed in, over the last hundreds of years and so forth. So if we apply that to the genome, then as you're mentioning, right, how do people just take this and make it actionable in their lives? So there's many commercial tests that are available now for genomics. There's the really familiar ones, 23andMe, Ancestry.com, and so forth. There's a whole bunch of additional tests that you can do across it. We're in the process actually of developing a new genetics test that will incorporate the kind of things I was talking about, where you have, these deltas of where your genetic predicts your potential and your actual measure, and it turns out the difference there. So that will be actionable for people specifically in a short period of time. So there are a lot of ways that you can come in and do testing. of that type. Certainly some of what, I'm doing at Thorne on microbiome and blood testing and all that, we have those tests available for people, as do other companies have some of those as well. And so there's a lot of ways that if someone really wants to do this, they can get into it. And Lee led a special media effort with Scientific American that came out a few months ago. I wrote an article in there that goes through, I don't know, 50 or 60 different companies in this space and all the products that they offer that are relevant to scientific wellness. So there's many entry points that people can get into.
Got it. And in your estimation, or your opinion, I should say, are all of those entry points equally good, or should people gravitate towards one or two that do things differently, perhaps?
Yeah, they're definitely not equal. Do you want to comment on that, Lee? Or I was going to say they're definitely not equal.
Comment on that. There are a whole series of actionable possibilities that come from the genome. For example, there are 76 variants that have been defined that cause diseases that are actionable in one way or another. And quite obviously, if you have one of those variants, it's something you want to act on. And to give you an example of one and how powerful this can be, there is a variant that's a dominant called malignant hypothermia. And the idea is if you have one bad gene for that, if you take the wrong anesthetic during a surgical procedure, it will turn up the heat in your body irreversibly and it kills you.
Wow.
So you should know you have that so that you know these 3 anesthetics you never touch ever, or they'll kill you. That's the kind of thing that can be very, very useful. A second area is an area called pharmacogenomics, and now there are probably hundreds of variants that people have that compromise their ability to use certain drugs. That is, you either metabolize them too fast or too slow, or they don't work in an appropriate way. And again, knowing about which drugs you can take safely and effectively, I think, is another major kind of possibility. And there are 7,000 rare variants, and 10% of the American population has these rare variants. And for a few, you want to learn them very early in life because you can do things to avoid the consequences. And these are increasingly going to be important in the future. And finally, to give you a more interesting example, there are hundreds of variants that affect your athletic ability. For example, there are variants that make ACL tears infinitely more probable. And there are things that you can do to countermand these limitations. And anybody interested in athletics and in fact, aging in a healthy fashion should learn at least about the major of these kind of things. And physicians vary in their acceptance of these kinds of variants, but there are a few major programs healthcare systems have pushed in the last 10 years or so. And I think the era of genomic medicine is coming, and more we'll see physicians accepting these as actionable possibilities. And again, you just have to be able to deliver them to the physicians in a clear manner that says both what to do and why they are doing it. The physician really demands what's the evidence for these kinds of things. And AI is an ideal tool by which this is going to be done. With the Million Person Project, which I'm pushing, we calculate that they'll generate probably another 10,000 new actionable possibilities in all dimensions of health. And that means AI is the only way you'll ever be able to deliver them to any physicians, because any physician, no matter what they are, only sees a narrow slice of medicine and what it is.
Mm-hmm. Very cool. Very cool. Okay, let's talk about the phenome, which you've talked about as a combination of your genome, your behavior, and your environment. How should people be thinking about their phenome? How can you measure it quantitatively, and what can you do about it?
Well, so let me just explain a word about the phenome. What your phenome is how you appear at each instant of your life. And across the 100 years or more of your life, you have an infinity of different phenomes. And what we want to be able to do is measure what are the events that make you what you are as a child, as an infant, as a young adult, and so forth. And it is the phenome. And the phenome brings together both your genetic source code, the DNA that regulates your development and aging and so forth, together with your behavior, which has a profound impact on diet and exercise and sleep and stress and all those other kinds of things, together with the environment in which you live, which can be healthy. The blue zones of the world that have ideal environments where people live beyond 100 typically because of very healthy environments and healthy diets and things like this, as opposed to life in some of the worst slums and things like that, where you're at the other end of the spectrum. So the idea is, if we're to assess your wellness as your health trajectory unfolds, we have to be able to make these measurements of blood, of the microbiome, of digital health, and so forth, and bring them together in this integrative way that follow the opportunities you have to manipulate major kinds of systems. And with Airavail, we came up with of the order of 200 different actionable possibilities that were largely focused on wellness. And we think that is going to increase exponentially. Mm-hmm. But the other thing, and maybe Nathan will want to talk about this, that we can do now is we have some really powerful metrics that allow us to make measurements every time, each 6 months we do the blood draw. One is your biological age, and that's equivalent to a wellness indicator. And the second is something we just got a paper published in Nature Medicine called your metabolic BMI, which is a much more flexible and accurate measure of your metabolism than the classic physical BMI. But Nathan, did you want to talk about either of those?
Sure. I'll just mention a couple things about that. So that ability to monitor the phenome, all these information out of the blood and stool and other sources, wearables, and all those things is obviously hugely important. So one of the things that I'm really focused on now is trying to make getting those measurements as easy as possible and as frictionless as possible for individuals. So I'll just give an example. So take microbiome. So microbiome is incredibly useful for health. You can learn a lot that relates to gut health and brain health because through the gut-brain axis and a whole host of things. So one of the problems, though, is that most people don't do a microbiome test. And one of the points of friction is that if you do a microbiome test, if you think about the physics or the ickiness factor of it or whatever, mm-hmm. This is, you've got a traditional test, you have to poop in a bucket or on a piece of paper. You got to take a little shovel, you got to scoop up a little feces, you got to put it in a vial. Some of the tests require freezing. I don't know what you keep in your freezer, but typically I keep food there. So I'm not so super excited about that. So there's all these barriers to people doing it. So one of the things that we did at Thorne was to think about, well, what's a way that we could let people take advantage of a microbiome test, make it easier? So this ended up in the development of something called the microbiome wipe, which is exactly what it sounds like. Basically, it's a special kind of toilet paper that you can't, so you just do what you have to do every day, but it turns it into a test that you can wipe, drop into a vial, close, you shake, it disappears in 10 seconds, and you preserve the DNA. And we published that we could get high quality DNA on that in Frontiers in Immunology. And so, but the reason I bring that up is, okay, that makes it much simpler. In fact, Sarah Gottfried, real well-known physician, best-selling author, was on the a competitive podcast, a big another podcast a couple of weeks ago. But it was interesting to say that, on there, she talked about that she had an NBA team, and they had refused to do microbiome testing. But when she instead used this wipe, they would all do it. And so that's like a simple way to just make the friction lower. We also have another device, I won't go into it in as much detail, that is for, virtually painless at-home blood collection. So you can just mail it to a person's house, and you can generate metabolomics data or proteomics data or all these different kinds. And now you don't even have to go into the hospital or into a phlebotomist. You can do it straight from your house. So these are things we didn't have a few years ago, that you can literally just organize and get these data and do it easy, frictionless. The cost is coming down, as Lee alluded to, and so forth. So this is all making it very practical, easy, simple for people to take actions of the kind of things that they learn about in the Age of Scientific Wellness, in the book.
Mm-hmm. Got it. So lots happening in terms of the tech that people can get in their homes, and there's less friction, like you said. Also, the processing isn't any less because we're getting more data points as the years go on. So, Nathan, you're a computer science guy. How long before we have the AI and we have the actionable insights that are validated by years and years of study or data, where we can tell these doctors, or for example, I don't necessarily need it to be a doctor, but how can I, as an individual, get a perspective plan of, here's what might not be the best, not optimized, and here's some things you can look at, right? The next step would be is to making it so easy that the doctors can actually interpret that data. And I think that might be a few years away. But in the perspective of consumer first and doctor second, how far are we from this using a technology and the backend systems standpoint?
We can already do a lot today. So, I don't see this as only something that's in the future. There's definitely information that you get right now, and it increases it increases radically as you go together. One of the things that I think is really important is what happens to these data. And it's one of the areas where, we need to have appropriate safeguards for people and things of that nature. But there also is an incredible virtue to sharing anonymized health data. And I got asked this question years ago, and I still think it's an interesting one, which was, what is the value of a genome? And it could be a proteome, metabolome. What's the value of health data? And the value of a genome increases every time there's another genome, because it lets us read more, it lets us learn more, like you're talking about. And so it's one of these incredibly virtuous cycles because you think of something like gold, right? It's some commodity. Why is it valuable? Because it's rare. And medical information is valuable when it's not rare, because you can learn so much from it that benefits everybody. So as I look at this today, you can definitely get in, like come back to the microbiome. So what are some of the kinds of things that, that a person could find out today? Well, you can find out things like, there's obvious stuff like, do I have pathogens that could cause, me disease? If I'm taking a probiotic and I want to see if it is in fact engrafting and getting in, because a lot of them will pass through you and not do anything. You want to see that? Well, you can test that. You can see that. If you're having issues of, irritable bowel syndrome, like we published a paper that showed that you could use personalized recommendations off this test to improve the symptoms of irritable bowel syndrome over a month period. We published that in Precision Clinical Medicine a couple of years ago. You can, learn about, there's a bunch of compounds that you want to be in your bloodstream, right? We did the largest study, I think, on microbiome metabolome at the time. There's a bunch of compounds you want in your blood that have to be made in the microbiome. Well, you can see if that is in fact happening. If not, you can, supplement with those. Serotonin a really important neurotransmitter, it's got to be made in your microbiome.
Mm-hmm.
And if it's not, well, there are things you can take that will improve that. If you're not, there are certain vitamins and nutrients that are made in your microbiome. Well, if you don't have the species that are doing that, you can know that, you can fix that, et cetera, et cetera, et cetera. I mean, there's all kinds of stuff you can do right now. And that's just one test. We could go through, the biological age, metabolome, all the other things all have the same kind of actionability. But what I would say is that there's already a lot you can do. And, one of the things that we really focus on is tying not just testing, but testing plus interventions, plus solutions. And that's what people really want, which is, something that will make a difference in, whatever issue that they're having. So I would say it's here now. It's already happening. There's good things you can do. And the future is much, much bigger as more of this data accumulates and insights grow and people share in that.
Mm-hmm. Okay, thank you. So if a consumer is listening and they seem inspired, they are inspired by your answer and they say, okay, the data's here, I can do this right now. How would they start? Do they have to go to one of these companies, get a DNA test, and then do they have to go to a company that does gut testing like yourself or a Biome or Ubiome or something and get that test? And then how do they get an integrative picture of what's actually going on and how the gut relates to the DNA versus what the metabolites are and the proteins in the blood? How will somebody put this all together?
Yeah, so it is, obviously that's my number one goal at Thorne, is pulling all this together into one unified position. And for, we have that to some extent for blood and for the and the microbiome. But today it is a little bit more federated. So you're right. There is a lot of this pulling from multiple sources or multiple companies. And we do have to pull that all together. That's what I work on, other than the occasional podcast, is what I work on all day, every day. So that's really important. And so it is a lot like the wearables have really been. And Apple Health and Common Health on the Android really came in and kind of helped centralize that. We're going to have to go through a similar process with scientific wellness and the deep analyses that we have, from blood and stool and all this, so that it all does live in an integrated place. You can get benefit from some of these things also through doctors. One group I'll mention is this Wild Health Network, which is quite interesting. They pull together, their dashboard actually is relatively similar to what we put together for Aravel, but with the added change that they're able to also work with physicians and doctors and be your primary care provider and so forth. That's a telehealth network. There's others like that, but there are these industries where you can get a healthcare professional, if you'd like, and tie into them, and they actually utilize a lot of the products and tests that we've discussed, and they will put that into a more integrated connection into your healthcare. So whether you just want to stay consumer and buy tests and monitor this in that sense, or you can also work with a kind of a network of providers that are plugged into this that can help navigate people through as well.
Okay, thank you. So Lee,
I'll add to that Phenome Health actually is beginning to formulate a company called Phenome for Me, which will do exactly what Aravel did before, only on steroids. Will make many more measurements and has the potential for being able to use AI so you can transmit more effectively to consumers through their physicians. So we're going to be really targeting clinical practices with this and making it dirt simple for these clinical practices to be able to look at 1,000 actionable possibilities that relate to all sorts of different kinds of things. So this is all going to be coming forth in the next year or two or so. So I would say stay tuned for these integrated visions that can deliver the whole suite of possibilities to individuals. And I think Nathan's answer is where you want to go in the short term. But I think in another year or so, we'll really have Phenome for Me up and operating in a distributed level where you can get engaged. The
Great.
one limitation right now is the cost of a lot of the phenomic measurements is higher than most Americans are used to paying, and we'll probably have choices about how much data we measure and make it cheaper or more expensive in that regard. But ultimately, what's clearly going to happen is this whole thing is going to move into the home. And you'll be able to do your blood test. You'll be able to send it out, get it analyzed. It'll go to your physician and indirectly back to you. We'll probably have avatars that will be personal health advisors to each family. And I think medicine, as we move into an era of wellness and prevention, is really going to move into the home and away from the big hospital systems and things like that. And this is, we're talking about a 10 or 15-year period, but it's really going to be exciting. And I think more and more we're going to develop tools that make the analyses cheaper. I mean, the Genome Project decreased the cost of genome sequencing from $1 billion for the first genome down to recently announced $100. So that's what, 10 to the 7th decrease in price. And what we hope to see as we start the Phenome project over the next 5 years or so is a decrease by at least 10-fold to 100-fold. And right now, a good phenome costs perhaps $6,000 a year, but if it could be 60 a year or even 6 a year, that's what we're going to be looking at in the future.
Mm-hmm. That's great. And that was one of my questions is where do you see this field or the future of medicine going? And so thank you for answering that. Nathan, do you have anything to add on to that conversation or that question?
Yeah, just we really see that the future of healthcare has got to move to be much more, it's got to intervene earlier, right? It's got to be much more proactive. There's no way that our current model, right, which is eating up now almost 1/5 of the economy in the United States, it's an unsustainable rate. It's bankrupting a lot of people, along with housing and education, right? The three big pillars that have gone up massively more than inflation for the last many years. So as we look at the future, I think this is going to the home. I think that people are going to get very engaged in, what we call scientific wellness, but this whole notion that you can take and harness so much more of your own health. And we should be able to deliver health benefits to people way more efficiently and way cheaper than we do now. And that's by empowering people with information, giving them easy to use solutions, making it available to the home and letting them have something that they can really drive and get the benefits of hopefully a very long, very healthy life.
That's great. Yeah, can't wait for the future. And I talk to a lot of folks in this area, like in longevity, anti-aging, wellness area. So I'm super excited about what's coming. And for people listening, just wait. There's even now, as Nathan said and Lee said, a lot of these technologies are available that you can start to integrate into your lifestyle. But the future is even wilder than we ever imagined in the next decade or two. Let me make one point, if I could, to close this off. And that is, if we take a systems approach to healthcare, you end up with P4 medicine, which is predictive, preventive, personalized, and participatory. And my point is the first 3 Ps, prediction, prevention, and personalized, are all science. And we really do know how to do the science. The 4th P is by far the biggest challenge. And that means, how do you persuade patients? How do you persuade physicians, healthcare leaders, healthcare technology leaders, regulators, politicians? How do you persuade them to replace a disease-oriented healthcare with a wellness and prevention-oriented healthcare? And I'd say that is the enormous challenge that we face. How do you, and maybe the biggest is with the patients themselves, how do you get people to realize
that their health trajectory is in their own hands, and they can make an enormous difference in that if they take some responsibility and not just wait passively for a healthcare system that's focused entirely on disease to try and do something for them.
Totally agreed. It's fascinating that we kind of let the doctor dictate. Even before we get to the doctor, we kind of don't think about health until there's a symptom. And then we wake up and say, oh my goodness, something is not right.
I've lost it. Yeah.
I've lost it. And then also that happens hand in hand with aging, because you start to see gray hairs in the mirror and you start to see more wrinkles. And slowly you go from indestructible to, oh, I guess I'm mortal. And I guess this is just what happens when you age. Oh, and then you talk to coworkers or somebody else and they have a disease and you're like, oh yeah, that's normal. I take these pills. And it just becomes normalized in society. And I think the message you guys are getting across is it doesn't have to be. Wellness can be until the day that you die, you could be well. And that's a very exciting future that a lot of us will look forward to. And so I think one of the takeaways that listeners can have from this episode is that the future is already here. And a lot of technologies are already here that can help reduce or catch these diseases that are going to be problematic later on, but they can catch them now. And you can basically get rid of or completely avoid those challenges if you just took a little bit of an innovative approach towards your health. So with that said, Lee and Nathan, thank you so much for coming on the Anti-Aging Hack Show. Where can people find you? Where can they get your book? What are your websites? Please tell us everything.
Yeah, so for me, people are interested in the 300 products or so forth we have and testing and so forth. That's at thorn.com. I'm also pretty active on LinkedIn, so we do posts and information and things like that periodically. So that's primarily where they can find me. Lee?
So I'm at lhood at phenomehealth.com. And also at the Institute of Systems Biology. The book is coming out on April 4th. You can actually plug into Amazon and have a reserved copy, which would be great for us because that ensures that you'll be on a popular list if enough of you get enthusiastic about the book. But I'll just leave you with the fact that if there's one thing that's important in your life and catalyzes and makes you more effective in every single thing you do, that one thing is health.
Mm-hmm. Mm-hmm. Okay. Well said. Again, thank you so much for coming on the Anti-Aging Hack Show, both of you.
Thanks, Faraz. Really appreciate it.